Listen closely. What you are about to learn will change the way you see the universe forever, because somewhere out there, 320 million light years from where you're sitting right now, a black hole is moaning. Not metaphorically, not poetically. NASA recorded it. And once you hear it, you will never believe space is silent again. For most of our lives, we were taught a simple fact in school. Space is a vacuum. Sound cannot travel through a vacuum. Therefore, space is silent. And technically, that statement is correct. Sound waves, the kind that travel through air and vibrate your eardrums, genuinely cannot move through the emptiness of space because there are no molecules to carry the vibration. But here is what they never told you. While sound cannot travel through space, something else can. Radio waves, electromagnetic radiation, plasma oscillations, pressure waves moving through hot gas, gravitational ripples bending the fabric of spacetime itself. And when NASA scientists take this invisible data and translate it into frequencies the human ear can actually process, the universe stops being silent. It starts to speak. This translation process has a name. It's called sonification, and it is one of the most fascinating, underappreciated branches of modern astrophysics. Sonification takes raw numerical data captured by space telescopes, X-ray observatories, and deep space probes, and converts it into audible sound using precise mathematical scaling. This is not artificial. This is not sound design added for dramatic effect in a documentary. This is real astronomical data, often collected over years or even decades, transformed into something our limited human senses were never built to perceive on their own. Today, we are going on a journey through the actual sounds of our universe, planet by planet, black hole by black hole, and by the end of this video, you will understand why scientists say space has had a voice the entire time. We just didn't have the ears to hear it. Let's begin with the most famous and most unsettling recording in NASA's entire sonification archive. The black hole sitting at the center of the Perseus galaxy cluster. In the year 2003, a team of astronomers using NASA's Chandra X-ray Observatory pointed their instruments toward this cluster, located roughly 320 million light-years from Earth. What they discovered was extraordinary. Surrounding this supermassive black hole was a vast cloud of superheated gas, and rippling through that gas were pressure waves, similar in concept to sound waves traveling through air, except on a scale almost too large to comprehend. These pressure waves were causing the gas to expand and contract in a rhythmic pattern, much like a drum being struck over and over again across millions of years. Here's where it gets strange. When scientists calculated the actual pitch of these waves, they discovered the black hole was vibrating at a frequency 57 octaves below middle C. To put that into perspective, that is roughly 1,000,000 billion times lower than the lowest note the human ear can detect. There was simply no way for any human being or any animal on Earth to ever naturally hear this sound. So in order to make it audible, NASA scientists had to scale the frequency upward by quadrillions of times, compressing nearly 57 octaves of sound into a range our ears could actually process. The result, when finally released to the public, sent chills down the spine of nearly everyone who heard it. A deep, continuous haunting moan, rising and falling in slow, deliberate waves. It does not sound like noise. It sounds intentional. It sounds almost alive. Scientists have described it as one of the eeriest sounds ever extracted from astronomical data, and for good reason. You are not listening to a recreation. You are listening to the actual vibrational signature of a supermassive black hole, slowed down and shifted into a range your ears can finally comprehend. But the Perseus black hole wasn't done surprising us. In 2022, NASA released an updated and expanded sonification of this same region, this time incorporating radar-like sweeps generated from the X-ray data surrounding the black hole's event horizon. The result was even more unsettling. Layered tones that almost resemble a low, rhythmic chant, echoing endlessly through the void. Social media exploded when this clip went viral, with millions of people calling it the sound of a black hole singing. NASA was quick to clarify that no effects were artificially added for dramatic flair. Every tone, every layer, came directly from real telescope data. The universe really did sound like that. Now let's shift our attention from black holes to planets, because it turns out our own solar system has been broadcasting sound for billions of years, and we only recently developed the technology to listen. Let's start with Saturn, the ring jewel of our solar system. Between 1980 and 1981, NASA's Voyager spacecraft made history by flying directly past Saturn, capturing data that would reshape our understanding of planetary science. Among the instruments on board was a plasma wave detector, designed to capture radio emissions in the space surrounding the planet. What Voyager picked up near Saturn's polar regions came to be known as Saturn kilometric radiation, a powerful burst of radio waves generated by auroras, similar to the northern lights here on Earth, but occurring on a planetary scale almost impossible to imagine. When NASA scientists converted this radio data into audible sound, the result was unlike anything anyone expected. A high-pitched, sweeping, almost musical whistle, rising and falling in waves, layered with crackling static and eerie tonal shifts. Online, this recording has often been mistaken for the sound of a UFO or dismissed as science fiction sound design, but the truth is far more incredible. What you are hearing is raw electromagnetic energy, generated by charged particles slamming into Saturn's magnetic field near its poles, captured by real scientific instruments, and simply made audible through mathematical translation. Saturn has been making this sound for billions of years. We just finally built the ears to hear it. Next, let's travel further out, to the largest planet in our solar system, Jupiter. NASA's Juno spacecraft has been orbiting Jupiter since 2016, conducting one of the most ambitious planetary missions in modern history. On board, an instrument called WAVES was specifically designed to detect electric and magnetic field oscillations in the space surrounding the planet. In 2021, Juno captured something remarkable as it crossed through the magnetic field lines connecting Jupiter to its icy moon Ganymede. When this plasma wave data was sonified, scientists were stunned by what they heard. A sudden, dramatic shift in pitch and frequency, almost like a sound effect ripped straight from a science fiction film. Rising electronic tones, sharp crackling static, and deep pulsing rhythms. But this wasn't artistic interpretation. This sudden frequency shift actually marked the precise moment Juno crossed into a dense region of charged particles near Ganymede's magnetic environment. In other words, scientists weren't just creating an interesting sound. They were listening to a real-time scientific discovery, unfolding in audio form, as the spacecraft physically moved through invisible structures in space. Now let's move even closer to home and talk about the planet that started this entire field of study, our own Earth. Long before NASA sonified black holes or distant planets, scientists were studying something called Earth's chorus, a naturally occurring electromagnetic phenomenon generated in our planet's magnetosphere. These chorus waves are created when electrons interact with Earth's magnetic field, particularly near the polar regions where auroras occur. When converted into sound, Earth's chorus produces an eerie, bird-like chirping sound, rising and falling in rapid, fluttering patterns. Scientists have nicknamed this phenomenon the dawn chorus, because the same way birds begin singing at sunrise, these electromagnetic waves intensify around dawn in Earth's magnetic field. It is a reminder that even our own planet, the one we call home, has been quietly broadcasting sound into space for as long as it has existed. We simply never had a way to listen until satellites gave us the tools to capture and translate this data. Now, let's go beyond individual planets and talk about something truly mind-expanding: the sonification of entire galaxies and nebulae. One of NASA's most visually iconic images is the Pillars of Creation, a massive structure of gas and dust located within the Eagle Nebula, roughly 7,000 light-years from Earth. This image, captured first by the Hubble Space Telescope and later in stunning new detail by the James Webb Space Telescope, shows towering columns of interstellar material where new stars are actively being born. In 2022, NASA's sonification team took this image and converted it into an entirely new kind of experience. Using brightness and vertical position data, they created an audio track that scans across the image from left to right, translating bright areas into higher pitch tones and darker, denser regions into lower, deeper rumbling sounds. As the sonification moves through the image, you don't just see the nebula anymore. You hear its structure. You hear the density of gas clouds. You hear the turbulent, chaotic regions where gravity is actively collapsing material into newborn stars. It transforms a static photograph into something almost cinematic, almost narrative, as if the nebula itself is telling its own story through sound. NASA didn't stop there. They applied this same sonification technique to the famous Crab Nebula, the remnant of a supernova explosion observed by ancient astronomers nearly 1,000 years ago. By combining X-ray, optical, and infrared data from multiple telescopes, NASA created a layered, multi-instrument sonification, where each wavelength of light produces a distinct sound, all playing together in a strange, hauntingly beautiful cosmic symphony. Layers of chimes, drones, and percussive hits, each representing a different type of radiation, captured from the violent aftermath of a star that died in a catastrophic explosion centuries ago. Now, let's bring this even closer to home, because even our own sun has a voice. Using data collected by NASA's Solar Dynamics Observatory, scientists have been able to sonify solar oscillations, essentially sound waves trapped beneath the surface of the sun. These pressure waves are generated deep within the sun's interior, and they can take several days to travel from the core to the visible surface. When this data is compressed and sped up into an audible range, the result is a deep, resonant humming sound, almost like the universe's own heartbeat. This field of study is known as heliosismology, and it isn't just for entertainment. Scientists use this exact sonified data to study the sun's internal structure, in much the same way doctors use ultrasound technology to examine the inside of a human body without ever needing to cut it open. So at this point, you might be asking yourself a very natural question. Why is NASA spending time, money, and resources turning starlight, radio waves, and X-rays into sound? Is this just for entertainment? The answer is far more meaningful than most people realize. First, sonification dramatically increases accessibility in science. For visually impaired students, researchers, and space enthusiasts, traditional astronomical images are simply inaccessible. Sonification allows these individuals to experience the same data, the same structures, the same cosmic phenomena, through an entirely different sense. A black hole, a nebula, a supernova remnant can now be experienced by someone who has never been able to see a single photograph of space in their entire life. This isn't just a nice gesture. It is a genuine expansion of who gets to participate in space science. Second, sonification has practical scientific value beyond accessibility. The human ear is remarkably good at detecting subtle patterns, rhythms, and irregularities, sometimes even better than the human eye scanning a graph or chart. By converting astronomical data into sound, researchers have occasionally noticed patterns, anomalies, or repeating structures that were difficult to spot visually, but became immediately obvious once translated into audio. In this way, sonification isn't just a tool for public engagement. It has become a legitimate method of scientific analysis. And third, and perhaps most powerfully, sonification reconnects us emotionally to the universe in a way that images alone cannot. There is something deeply moving about realizing that a sound you are hearing right now traveled for hundreds of millions of years before reaching a NASA instrument, was captured as invisible radiation, and was then translated specifically so that a human being, sitting comfortably on a small blue planet, could experience even a fragment of what is happening across the vast emptiness of space. It collapses the unimaginable scale of the universe into something personal, something almost intimate. Let's take a moment to talk about how this technology has evolved over time. Because the journey from Voyager's primitive plasma wave recordings in the early 1980s to today's incredibly detailed multi-wavelength sonifications represents decades of technological advancement. Early sonification efforts were relatively simple, taking a single stream of data and directly converting frequency into pitch. Today, NASA's sonification team, working alongside the Chandra X-ray Center, regularly combines multiple data sources, X-ray, optical light, infrared, and radio data, into single, layered audio experiences. Specialized software now allows scientists to assign different instruments, different tones, different stereo positioning, and different volume levels based on incredibly specific scientific parameters like brightness, density, temperature, and distance. What was once a niche scientific curiosity has become a sophisticated, almost orchestral method of representing complex astronomical data. It's also worth mentioning some of the lesser-known sonifications that have emerged in recent years, because the universe has far more voices than most people realize. NASA has sonified gravitational wave detections from colliding black holes, captured by the LIGO Observatory, producing a short, eerie chirp that represents two black holes spiraling into each other and merging into one, releasing energy equivalent to billions of suns in a fraction of a second. They've sonified the rings of Saturn themselves, using data from the Cassini spacecraft, capturing the way countless ice particles interact with the planet's magnetic field. They've even sonified the cosmic microwave background radiation, the faint afterglow of the Big Bang itself, transforming the oldest light in the universe into a deep, ambient, almost meditative drone. When you step back and look at the full picture, what emerges is genuinely profound. Every single sound we've discussed today, the black hole's haunting moan, Saturn's electromagnetic whistle, Jupiter's crackling plasma waves, the nebula's shifting tones, the sun's deep resonant hum, has been traveling through space for years, decades, centuries, sometimes millions of years, completely silent to human ears until extremely recently. We are, quite literally, the very first generation in the entire history of our species capable of listening to the actual sound of dying stars, colliding black holes, and newborn solar systems. Not a sound effect created in a studio, not a dramatized recreation for a documentary. Real astronomical data, collected by real spacecraft, translated through real mathematics, made audible for the very first time in human history. Space was never truly silent. We simply didn't have the technology to listen. And now that we finally do, the universe has far more to say than any of us ever imagined. If today's journey through the secret sounds of space changed the way you think about the cosmos, make sure you subscribe and turn on notifications. Because next time, we are going even deeper into the recordings NASA almost never released to the public. The sounds that even scientists describe as too strange to fully explain.